Let us start with Module 6, Computer Aided Design, CAD. So what is CAD? CAD is the use of computer software to design and document a product's design process. That means we can use CAD for designing a variety of products, as well as we can document that design process. That means the various steps involved in the design, the various mathematical calculations, etc. can be kept as a document using CAD. So CAD can be used for creating 3D models of physical objects. Nowadays, CAD is widely used by designers, engineers, architects, etc. CAD can be used for creating a variety of new models for a wide range of industries. So why CAD becomes this much popular now? What is the importance of CAD? All of us are familiar with engineering drawings. So we know we have studied engineering drawings and engineering graphics. So engineering drawings gives detailed information about a component in a graphical form. So we know engineering drawings usually conveys a lot information about that particular component, its structure, its dimensions, everything. So what is the importance of this engineering drawing? Why do we have to make engineering drawings? So there are two main reasons for that. One is, we know that visual objects are more important than languages. Say for example, consider the design of a generator. Consider the construction of a generator. So we get an idea about the construction if we get a verbal description about it. So if someone is explaining verbally the construction, we'll get an idea about it. And also if we are reading a description in words, we'll get an idea. But if a three-dimensional view of that machine is shown, which is showing the constructional details, it will be more clear to us. We'll get more idea about the construction by seeing that three-dimensional figure. That is, visual objects can convey more information than languages. So that is one of the importance of engineering drawings. Another one is that solving any problem in engineering sector requires a graphical representation of the problem. So we need a drawing. So due to these reasons, engineering drawings are very important. And in older days, the engineering drawings were handmade. നമുക്കറിയാം ഗ്രാഫിക്സ് ആണെങ്കിലും മുമ്പുള്ള സിലബസിലൊക്കെ നമ്മൾ വരച്ച് തന്നെ ആയിരുന്നു പഠിച്ചത് ഡീറ്റെയിൽഡ് ആയിട്ട്. പക്ഷേ ഇപ്പോൾ ആ ഗ്രാഫിക്സിന് ആ പർട്ടിക്കുലർ പേപ്പറിനുള്ള ഇമ്പോർട്ടൻസ് കുറച്ചു. നിങ്ങളൊരു ആൻസർ ബുക്ക്ലെറ്റ് തന്നെ വരയ്ക്കാൻ തുടങ്ങി. വൈ? ബിക്കോസ് ഹാൻഡ് മെയ്ഡ് ഡ്രോയിങ്സ് ആർ നോട്ട് പോപ്പുലർ നൗഡേയ്സ്. It is computerized. We are using CAD for making engineering drawings. Okay, so in older days, all the engineering drawings were handmade. So at that time, it was very difficult to make drawings. It was time consuming, errors may occur, so lots of problems were there. And a solution to all these problems is the introduction of CAD, Computer Aided Design. So with the introduction of CAD, we can easily design and develop products. And also, the products can be optimized. So what do you mean by optimization? So optimization is nothing but the choice of best design. So suppose we have to design a product using CAD. There is not only one design for that particular product. Any product will have a number of alternate designs. പല രീതിയിൽ നമുക്ക് അതിനെ ഡിസൈൻ ചെയ്യാം ബൈ വേരിയിങ് ദ പാരാമീറ്റേഴ്സ്. ഡിഫറെൻറ്റ് പാരാമീറ്റേഴ്സ് യൂസ് ചെയ്ത് ഡിഫറെൻറ്റ് ഡിസൈൻസ് നമുക്ക് ഒബ്റ്റെയിൻ ചെയ്യാം. സോ സെലക്ടിങ് ദ ബെസ്റ്റ് ഡിസൈൻ ഫ്രം that means optimization. So if we are using CAD for designing a particular product, as it is computerized, it can produce a number of designs within a very short period of time. It can produce a number of alternate designs. It can perform calculations very easily, and it can give a number of designs. While if we are manually designing that, the number of alternate designs that we can make is limited. So here comes the importance of CAD. It can make a number of designs in a very short period of time, and from that it can take the best design. And also CAD is nowadays used in the design of tools required in manufacturing process as well as in the construction domain. So it is used for making tools and equipment used in manufacturing process as well as in the construction domain. So it is having a wide variety of applications, manufacturing processes and construction domains, that means civil engineering domains, etc. CAD is having a wide variety of applications. So here these are some of the pictures of fields where CAD is used. So this is a CAD drawing of an electrical circuit. So in electrical engineering it can be used for making two-dimensional views of electrical circuit or three-dimensional models of electrical machines, etc. Also this is a three-dimensional view of a car. So it is used, CAD is very useful in automobile industry. So this is how a design of a building is made using CAD. And also CAD is used for making apparels, for designing dresses, and many other applications are there for CAD, like interior designing, design of our household objects, etc. Everything requires CAD now. So now let us see what are the uses of CAD. So CAD helps to create 3D models, to make preliminary designs and layouts, and design details and calculations, etc. So we have already discussed all these points in the introduction section itself. Now, CAD facilitates the manufacturing process by transferring detailed information about a product in an automated form that can be universally interpreted by a trained personnel. Suppose if a product is designed using CAD, then that CAD document related to that particular product will contain all the informations related to the design of that particular product, and that informations can be interpreted and it can be understood by any other person who is an expert in CAD. So CAD യൂസ് ചെയ്ത് നമ്മൾ ഡിസൈൻ ചെയ്ത ഏതൊരു പ്രോഡക്റ്റിനും റിലേറ്റഡ് ആയിട്ടുള്ള എല്ലാ ഇൻഫർമേഷൻസും അതിൻ്റെ ഡിസൈൻ ഡീറ്റെയിൽസ് എല്ലാം ആ അതിൻ്റെ CAD ഡിസൈൻ്റെ കൂടെ അവൈലബിൾ ആയിരിക്കും. CAD അറിയാവുന്ന ഏതൊരാൾക്കും അതെല്ലാം ഇൻ്റർപ്രറ്റ് ചെയ്യാൻ പറ്റും. സോ ഇറ്റ് ഇസ് എ യൂണിവേഴ്സലി അക്സെപ്റ്റഡ് ഫോമാറ്റ്, യൂണിവേഴ്സലി ഇൻ്റർപ്രറ്റബിൾ ആയിട്ടുള്ള, യൂണിവേഴ്സലി എല്ലാവർക്കും മനസ്സിലാവുന്ന ഒരു ഫോമാറ്റിലായിരിക്കും CAD ഇൻഫർമേഷൻസ് എല്ലാം സ്റ്റോർ ചെയ്യുന്നത്. So CAD can be used to produce either two-dimensional or three-dimensional diagrams. The use of CAD software allows the object to be viewed from any angle. So we know we actually need the view of a particular object from different angles. So in engineering drawings we draw plan of an object, the elevation, the front view, the side view, etc. So if we are drawing it by ourselves, if the drawings are handmade, we have to separately draw each of these views, the top view, the side view, etc. We have to separately draw. But if we are making a three-dimensional model of that particular object in CAD, we can view that object in any direction, from any angle, simply by rotating that particular object. And we can view that object even from the inside of that object. So that is one of the importance of CAD. And CAD, another main advantage of CAD is that with CAD, editing is a very fast process compared to manual method. We know how much time it takes in order to make a correction in a handmade drawing. It is very difficult. But with CAD, editing is very fast. CAD reduces the design time by allowing precise simulation rather than building and testing physical prototypes. Okay, suppose we have to design a particular machine. Without CAD, we are manually doing it. So we have to make a number of alternate designs. Then from that we have to choose the best one. And based on that design parameters, we have to physically construct a machine. സോ നമ്മൾ മാനുവലി കാൽക്കുലേറ്റ് ചെയ്ത് ഡിസൈൻ ചെയ്ത് ആ വാല്യൂസ് വെച്ചിട്ട് നമുക്കൊരു ഫിസിക്കൽ പ്രോട്ടോടൈപ്പ് ഉണ്ടാക്കണം ആ മെഷീൻ്റെ. എന്നിട്ട് വി ഹാവ് ടു ടെസ്റ്റ് ഇറ്റ് ആൻഡ് സീ വെദർ ഓൾ ദ റിക്വയർഡ് സ്പെസിഫിക്കേഷൻസ് ആർ മെറ്റ്, ഇഫ് ഇസ് ദ പെർഫോമൻസ് ഇസ് സാറ്റിസ്ഫാക്ടറി. ഇപ്പോൾ ഇലക്ട്രിക്കൽ മെഷീൻ ആണെങ്കിൽ അതിൻ്റെ ടെമ്പറേച്ചറൊക്കെ വിത്തിൻ ലിമിറ്റ് ആണോ, റിക്വയർഡ് എഫിഷ്യൻസി കിട്ടുന്നുണ്ടോ. So like that, all these factors have to be checked on a physical prototype. But in case of CAD, we need not have to build a physical prototype. We can make a model of that object in CAD, make a three-dimensional design of that object in CAD, and we can simulate it. അതിനെ ആ മോഡലിനെ സിമുലേറ്റ് ചെയ്ത് CAD-ൽ തന്നെ നമുക്ക് ടെസ്റ്റ് ചെയ്യാം. ആ മോഡൽ നമ്മൾ ഫിസിക്കലി കൺസ്ട്രക്ട് ചെയ്താൽ അതിൻ്റെ പെർഫോമൻസ് എങ്ങനെയായിരിക്കും. ഒരു ഇലക്ട്രിക്കൽ മെഷീൻ ആണെങ്കിൽ അത് വർക്ക് ചെയ്യുമ്പോൾ അതിൻ്റെ ഡിഫറെൻറ്റ് പാർട്സിൽ വരുന്ന ടെമ്പറേച്ചർ ഡിസ്ട്രിബ്യൂഷൻ, ഹീറ്റ് ഡിസ്ട്രിബ്യൂഷൻ എങ്ങനെയായിരിക്കും. ഫ്ലക്സ് ആണെങ്കിൽ ഫ്ലക്സ് ഡിസ്ട്രിബ്യൂഷൻ എങ്ങനെയായിരിക്കും. Potential distribution. So different factors like this can be checked using that CAD software itself without the need for making a physical prototype. So now, by integrating CAD with CAM, CAM means computer aided manufacturing, it streamlines the product development even more. So products can be designed using CAD, and if the manufacturing process is also computerized, then the product development becomes very faster. Now we can design products or objects using CAD. We can make three-dimensional views, and we can take a printout of that using a special printer or plotter. And CAD program uses either vector-based graphics or raster graphics. So in CAD we have to make three-dimensional or two-dimensional images or models. And for that, it uses either vector-based graphics or raster graphics. So now let us see what are vector-based graphics and raster graphics. So these, both of them are two methods for forming images or models. So in vector-based graphics, see, a line is shown here. So this black line is shown, and this is the zoomed view of that line. So in vector-based graphics, all the images are formed with using lines or curves, points, etc. So if we zoom that, it will look the same. It will not lose the clarity. So in raster-based graphics, all the images are formed with the helps of tiny pixels. So the zoomed view will look like this. So in CAD, the three-dimensional or two-dimensional models of objects can be formed using either this vector-based graphics or raster graphics. So next is the classification of CAD software. So we have already said that CAD can produce either two-dimensional or three-dimensional models of objects. So depending on that, CAD is broadly classified into two types: two-dimensional CAD or 2D CAD, and three-dimensional CAD or 3D CAD. So 3D CAD is further classified into three types: wireframe model, surface model, and solid model. So now let us see each of these in detail. So first, the two-dimensional CAD. So the 2D CAD is the pioneer of CAD software, and it was developed in the early 70s. So 2D CAD is the primarily introduced CAD software. Initially introduced CAD software is the 2D CAD, and it was in the early 70s. During 1970s it was introduced, and at that time, during 1970, most of the companies, most of the automobile, aerospace companies, etc. developed their own tool, in-house tools for automating the repetitive drawing requirements. So അങ്ങനെയുള്ള കമ്പനീസിലൊക്കെ, ഓട്ടോമൊബൈൽ, സ്പേസ് ക്രാഫ്റ്റ് കമ്പനീസിലൊക്കെ എഞ്ചിനീയറിംഗ് ഡ്രോയിങ്സ് ഉണ്ടാക്കേണ്ട ഒരു റിക്വയർമെൻ്റ് ഉണ്ടായിരുന്നു. കണ്ടിന്യൂസ്ലി they had to make drawings, and in order to automate that process, those companies made their own CAD softwares during that time. And 2D CAD depends on basic geometric shapes like lines, arcs, curves, circles, points, etc. for making drawings. So they are flat drawings. Two-dimensional drawings means flat drawings that we can draw on a plane, which can be represented on a plane. That are two-dimensional drawings. And this type of softwares have been first developed way back in 1970s. 1970s-ലാണ് അത് ഡെവലപ്പ് ചെയ്തത്. We have already said that. Now, Autodesk is one of the pioneering companies that have played a significant role in the development of CAD software. So Autodesk was the main company, the company which first started developing CAD. So the company Autodesk has contributed more in the development of two-dimensional CAD software. So now let us see the three-dimensional CAD. So we know three-dimensional CAD is a step up, is an improvement of the older two-dimensional CAD software. So as time passed, the processing capabilities as well as graphic display capabilities of computers improved, and with that we could develop three-dimensional images of objects. So 3D images, we know 3D images are more realistic. So it is an improved version of two-dimensional CAD. So here we will get isometric and perspective views from any angle using 3D CAD. So you may have studied this isometric and perspective views in engineering graphics. So as we are producing three-dimensional models using 3D CAD, that particular object which we have designed can be rotated in any direction, or it can be viewed from any angle. And this 3D CAD was introduced in 1980s by a partnership between IBM and Dassaults. So 3D CAD became popular because of its enhanced visual capability. So it is a 3D image, so it is more realistic. It can be viewed from any angle. So it became popular easily, rapidly. The rapid advancement of 3D software today has helped quick turnaround in product design, giving birth to the concept of product lifecycle management. So 3D CAD has advanced very rapidly. So അത് വളരെ പെട്ടെന്നാണ് ഈ 3D CAD technology popular ആയത്. So with the use of 3D CAD technology in industries, there was quick turnaround in product design. There was a very sudden improvement in product design. വളരെ എളുപ്പത്തിൽ റാപ്പിഡായിട്ട് പ്രോഡക്റ്റ് ഡിസൈൻ ചെയ്യാൻ പറ്റി. And it also gave birth to the concept of product life cycle management. So you may have studied this term also, product life cycle management in sustainable engineering. So product life cycle management is nothing but the management of entire life cycle of a product. അത് ഇൻട്രൊഡ്യൂസ് ചെയ്ത്, ഡിസൈൻ ചെയ്ത്, മാനുഫാക്ചർ ചെയ്തു, അത് ഒരു സർവീസിന് വേണ്ടി ഉപയോഗിച്ച് കഴിഞ്ഞ് അതിൻ്റെ ഡിസ്പോസൽ വരെയുള്ള ആ ലൈഫ് ടൈം അത് മാനേജ് ചെയ്യുന്നതിനാണ് പ്രോഡക്റ്റ് ലൈഫ് സൈക്കിൾ മാനേജ്മെൻറ്റ് എന്ന് പറയുന്നത്. സോ ആ കോൺസെപ്റ്റ് വരെ ഈ CAD-ൻ്റെ ഇൻട്രൊഡക്ഷനോടുകൂടി വന്നതാണ്. So now examples for a few 3D CAD softwares are Solid Edge, SolidWorks and Unigraphics NX. So now let us see which are the different types of 3D CAD technologies. So first one is the wireframe model. So as the name indicates, this wireframe models appears to be made up of wires. Wires കൊണ്ട് കൺസ്ട്രക്ട് ചെയ്തതുപോലെ ഇരിക്കും. They create skeleton-like models with lines and arcs. So skeleton-like model importance എന്താ? What is the speciality? Everything in the background is visible. So if a structure, a model is made with the help of lines and arcs, what happens? Everything in the background is visible. So it is known as wireframe models. So this is the example of wireframe model of a cube. So next one is the surface model. So in surface models are created using three-dimensional surfaces created by joining three-dimensional surfaces. So this is how a surface model of a cube looks like. Here nothing in the background will be visible. So they are more realistic compared to the wireframe models. So the last one is the solid model. So a solid model is the most useful CAD model. So this is the solid model of a cube. So this is the most realistic model. So we know. So even if it is almost similar to the surface model, it has some of the properties like an actual physical objects. ഏതൊക്കെ പ്രോപ്പർട്ടിയാണ്? Solid models will have weight, volume, density, etc. like the actual physical object. And these solid models are commonly used as prototypes to study engineering designs. So these solid models, as this is the most realistic model, these are used as prototypes for engineering studies. നമുക്കിപ്പോൾ ഒരു മോട്ടറിനെ കുറിച്ച് സ്റ്റഡി ചെയ്യണം, അത് ഡിസൈൻ ചെയ്താൽ അതിൻ്റെ പെർഫോമൻസ് എങ്ങനെയായിരിക്കണം എന്നൊക്കെ നമ്മൾ ചെക്ക് ചെയ്യണമെങ്കിൽ നമ്മൾ ഏതാണ് ചെയ്യുന്നത്? മോട്ടോറിൻ്റെ ഒരു സോളിഡ് മോഡൽ ക്രിയേറ്റ് ചെയ്തിട്ട് ചെയ്യുന്നതായിരിക്കും ഏറ്റവും എഫക്റ്റീവ്. So these are the various types of CAD softwares.